Welcome back, guys. We're still in the functions. And I just want to say something here. Is that let's go to our PowerPoint. Same idea which we did on the board right now about the domain and the range. And we had before what the meaning of the range is for the domain for X and the range for Y. Then we said something like this. We have to arrange the numbers ascending from the lowest number to the highest number. And we moved forward into the slide, and we saw the domain is for X and the range is for Y. And we are done for this. Then we draw this on the board in front of you right now. Y equals 2x minus 5, and it gave a linear function. It's a linear function. Linear means that the power of the x is 1. The power of this x is 1. So it's not quadratic, not cubic, not... so here, and this is the y and t. The y and t means the point of the y here is minus 5, because you can see here on the y is minus 5 here. Like you see the intercept here, the intercept of the y is minus 5, like we said before. Y is minus 5. One thing more I just want to say here is that this is a linear function, and it's a function because we draw a line. This line, this green line, we draw it. It intersects with the curve or the line in one point, which means this is a function. This is a function. Likewise, the same idea, but only this will be quadratic because it's a square here. The x here is a square, so it will be quadratic. Same ideas and same things we did. We'll put values for x, 1 and 2 and 3 and 4 and 5, and then we'll see how y will behave like. Look at this now. So here I put for x minus 1, 0, 1, 2, 3. I assume these values for x. Then I'll check what are the correspondence values for y. In that case, what will be the correspondence? As example, let us say here, let me put x equal minus 1. So minus 1, this is minus 2. Multiply will be 4. 4 plus 3, that will give me 7. You guys got it? Again, x here equal minus 1. We'll assume that x will equal minus 1. Then here, minus 1 minus another 1, all square, that will be minus 2 square, means 4. 4 plus 3, that will equal 7. Okay? Okay. The second point, I will assume that x will equal 0. I will assume that x will equal this 0. Like here, I will assume that x will equal this 0. Here, this 0, x will equal 0. Then 0 minus 1 all square. 0 minus 1 will be minus 1. Minus 1 all square means minus 1 multiplied by minus 1. That will equal 1. Plus 3, that will equal 4. Here we go. The value is 4. And the third, I assume that x equal 1. So 1 minus 1, this will be 0. 0 plus 3 will be 3. After that, 2, I assume that x, I am the one who put these numbers. I am the one who decide these numbers. X will equal 2. 2 minus 1, that's 1 all square, will be 1 plus 3, that will give me 4. And finally, I will assume that x will equal 3. 3 minus 1, that's 2. 2 all square will be 4. 4 plus 3, that will give me 7. Now I will grab these points. So I would say minus 1 goes to 7. Here is minus 1. I will move forward to the left, minus 1, and I will go up till 7. Here is the point, minus 1 and 7. The first point is minus 1 and 7. X minus 1, y 7. So x minus 1, I will go to the left, minus 1. Then y 7, I will go up, positive in the y, till 7. The second point is 0 and 4. So 0, I will move 0. I will not move anything. Then I will go up 4. Here it is, in this point. Here, you can see it here. Third, 1 and 3. 1 and 3. So I will go to the right one. and go up 3. Here it is. I will go up 3. And this is the point. 2 and 4. So here I will move 2 to the right and go up 4. Finally, 3 and 7. I will go to the right 3, then go up 7. Here is the point. Then I will connect all these points together like this way. It made for me a curve, but this curve does not start from 0 and 0 points. Yes, it's a symmetry, means it has two sides very similar, but not on the point of 0 and 0. It doesn't pass with the point 0 and 0. But still, wait a minute. If we want to say the domain now, x can be any numbers from minus infinity into positive infinity. So x belongs to real numbers. That's no problem about this. X, the domain x belong to real numbers. So any real number can go for x. Any number from minus infinity to positive infinity. That's all can go for x. But why? Y did not start here. Why? If you see y started, we left 3. 1, 2, 3. So it didn't reach to 0 and 0 actually. So y here is greater than 3. Is not less than 3, is greater than 3, because we started the y here and from the two sides. It's minus infinity and positive infinity, but here it is greater than 3. So we can graph it like this and say y belongs to real numbers, but with a condition that y is greater or equal to 3. Y, because this is a y-intercept, is more than 3. Here is 3, 1, 2, 3, and y is above the 3. So this is the figure of this graph. Remember that the R is not, it's real numbers, but there is a condition here, because it didn't start from 0 and 0, or it took a figure of shape that it's more than 3 here. More than 3. For that reason, we said y is greater than 3. Y, the domain of y is, or the range is greater than 3. This is another example. We'll go to the next one. This example of a radical function means there is roots here. We have roots here. Same idea, same everything, but there is the x here is under the root. X here is under the root. So here we also will assume values for x, then check out for the values of y. We'll assume values for x, then check out for the values of y. That's nice. So if, as example, this we call it radical function. Why radical function? Because there is a root here. X minus 1 here, this is a root. For that reason, we call it radical function. Okay, does make sense? Same like other things which we did before. So as example, I will assume values like 1, 2, 5, 10, whatever, any values for x, any values. But I cannot put x actually to be equals less than 1. I cannot put x will be 0. No. Why? Because if I put x equals 0, it will be 0 minus 1. That will be minus 1 under the root. It will not be definite number. It will be impossible because there are no roots for the minus. There are no roots for the minus. So x must be equal 1 or more. X must equal 1 or more. The reason for this is that if I put x as example with 0, 0 minus 1, that will give me minus 1 under the root. This is impossible. Roots are always for the positive numbers, no roots for negative numbers. So I have to put this in the concern. So for that reason, when we go to get the domain of x, we'll say x belongs to all real numbers. But with one condition here, there's a condition here, is that x is greater than or equal 1. So it means that I cannot put x less than 1. I cannot assume that x is less than 1. I always put x equal 1 or more. So here, 1 minus 1, this is 0. The root of 0 is 0. Plus 3, that will give me the y will equal 3, because y will equal the root square of x minus 1 plus 3. So here, the same thing. I will assume that x will equal 2. That's right. As long as x is greater than 1 or equal 1, that's fine. But don't assume that x will be less than 1, because if it is less than 1, under the root will be 0, and this is impossible. There is no solution here. Then here, 2 minus 1, that will be 1. The root of 1, the root of 1 is 1. 1 plus 3, that will give me 4. The third number, I assume 5. 5 minus 1. And I put this number always, so that when I get the root, it will be a real number. No integers, no fractions, nothing. It will be a real numbers. I can put 3 and 4 and 5. But I just jump from 2 to 5. The reason I jump for this is to look for a number which has a root. A real number has a real root. For that reason, I said 5 minus 1, that will give me 4. The root of 4 is 2. 2 plus 3 will give me 5. Likewise, the last one, x will equal 10. We'll assume that x will equal 10. 10 minus 1, that is 9. 10 minus 1, this is 9. I will get the root square of 9, which is 3. 3 plus 3, that will give me 6. Cool, that's very nice. Now we'll go into the domain and the range. The domain and the range. Here, we see like what you see in front of you here. We said the domain of x is larger than 1, and the domain of y is greater than 3, because 3 here will be the lowest number which we will have, because never be less than this. The outcomes will never be less than 3. So y here will start from the 3. Okay, guys, y did not start from here or from here or from here, because all these numbers will be negative under the root, and it will be impossible solution. So the first range for the y is from 3. The y will equal 3. Right? Here it is. So y will be greater than 3. Y will be belonging to the real numbers with the condition y is greater than 3. The same thing, the same idea of the previous example. In this solution, like you see here, we are between -6 and +6. So the range is between -6, here it is, and +6 in this area. This is the domain because x is in this area. X is limited between those two areas, between -6 and +6. How about y? Y also the same thing. Y is between -6, because this is the y, and y equals 6. So y is between -6 and 6. So these are the domain of this. But actually, this is not a function, because if we drop a vertical line here, if we drop a vertical line anywhere here, it will cut into 2. It will intercept in 2 points. And the function intercept in 1 point only. With the function, the vertical line which we draw must cut only 1 point to be a function. But those are 2 points, so this is not a function. This is not a function. Y will equal 1 divided by x plus 3. In this, I say that x will never equal -3. Why? Because if x equal -3, -3 plus 3, that will be 0. 1 divided by 0, that will give me infinity. So this will be impossible, no solution here. So x can be any number, but not -3. X can be any number, but not -3. The reason? Because if I say y will equal 1 divided by x plus 3, and I will say assumed that x will equal -3, then 1 divided by -3 for the x plus 3 that will equal 1 divided by 0. This is infinite or no solution. In that case, x is not minus 3. All the real numbers, but x is not 3. For that reason, see, here we say x are all real numbers, but x does not equal minus 3. And y does not equal 0. Also, the horizontal asymptote at y equals 0 here. So here y will never equal 0. Means y will never touch the 0. Y will never touch the 0. Because any value here you give to these numbers will never make y equal 0. Y will equal 0 when if this was 0, because 0 divided by number will give me 0. But y here never equal the 0. For that reason, you find it asymptote, or the horizontal asymptote at y equals 0. So the asymptote means that it's coming close by the y, but it will never touch it. It will never intersect it. This is the meaning of asymptote. So here we would see horizontal asymptote at y equals 0. Okay, y equals 0. So here it is. This is y equals 0. Here it is. Y is 0. The horizontal asymptote at y equals 0. Because we say y will never equal the 0 means it will never intercept with the y axis. In this function, y equal 1 divided by x plus 3, it has two asymptotes. Vertical asymptote, division by 0 is undefined. And we have horizontal asymptote as well. That was the first part of the function and the function notations. Shall see you on the next part. Thank you so much.